All right, well, let's see. We're in Tech Math 2. And we're going to cover section 9.1 and 9.2 today. And which means 9.1 and 9.2 have to be really easy, right? In order for us to get done today. All right, so 9.1 has to do with exponential. So I have something y is equal to b to the x. We call it b because we're going to call this the base. What are we going to call this guy here anyway? It'll probably come an answer. Let me think. This guy up here, I think we call him the mantissa. M-A-S, man, T-I-S-A. Think we do? Yeah, probably not. We probably just call him the exponent. Anyway, but that's why it says B for base. So the issue is, how are we going to graph functions that are in the form y is equal to b to the x? Well, the way we do that is we make up a table. And we say x is this, y is that. We find points on it, and then we go and we draw the curve. Whatever it might be. All right, so that's the plan. And we'll start with number 23. 23. Y is equal to 2x squared. Okay, well, we'll x's and y. So when x is 0, y is 1. So isn't that good? We have a point already. Right there, y is 1. When x is 1, y is going to be 2. Now we have 2 points. When x is minus 1, y is going to be 2. Okay, so that'd be a point up there. And when x is 2, y is going to be 16. 16 way up there. And I have on pretty good authority, minus 2 is going to be minus 16. It's going to be 16 as well. Okay, so now we have enough dots. We connect the dots. And we say, well, that looks like my curve. Well, that's pretty funny. That doesn't look anything like the curves in the rest of the chapter. Looking at 39. Is there really a 43? Yes, there is. Okay. Looking at 39. Well, we better do another one of these, right? We'll do 14. Y is equal to 5 to the minus x. All right, let's see. When x is 0, y is 1. When x is 1, y is 1/5. When x is 2, y is 1/25. When x is minus 1, I got a 5. When x is minus 2, I get a 25. All right. So we see an obvious thing here that at x is equal to 0, I'm always getting a 1, right? Okay, so I got a 1. If I go this way, I get smaller very quickly. And if I go that way, I get larger very quickly. And now I can draw a curve. Excellent. Does it matter that I missed going through my dot on my curve? No, definitely not. Doesn't matter. Okay. Number 39, we want the 6th root of 140 to 3 significant digits. Okay, well, let's see. My calculator has a button. It's above the, it's below the pi button. And so if I put in a 6, second function, nth root key, and I put 140 in, and I hit the enter button, I end up with the 6th root of 140 is equal to 2 point, how many significant digits? 3, 2.28. Okay, so if I can make my calculator do it, I'm good. If I can't make my calculator do it, then Is there any other way to do that, I wonder? 2 times 70, 2 times 35, 5 times 7. No, there's no other way to do it than to put it in my calculator. Right. Number 43. We have a formula for compound interest. So the amount of money I have is the amount of money I used to have, 1 plus the rate divided by the number of times I do it per year times, is it xn? Xn. And being the number of years that I do it. Assume that you have $1,000 invested. Okay, so $1,000 invested, and the rate is 8%, so that's 0.08, and I'm going to compound annually. Okay, so that's going to be a 1, and I'm going to raise that to the third power number of years. 3 years, right? Raise it to the third power. Okay, so that's gonna be my A answer, and then I'm gonna do it again, and I'm gonna say 1,000 1 plus 0.08. Semi-annually means twice. Raise to the 6th power. That's going to be my B answer, and then I'm going to do it again. 1,000 1 plus 0.08, and I'm going to give interest daily. Is it 365? 365.25, right? Raised to the 3 times 365.25, and that's going to be my C answer. Oh, wait a minute. I forget. No, that's going to be my D answer. And then I got a quarterly answer, which I didn't put down. 1,001 plus 0.08 divided by 4 to the 12th power. That's my C answer. Okay, now I've got them all written down. Now I can start putting them in my calculator. So 1,000 times parentheses 1 plus 0.08 close parentheses raised to the 3rd power equals. All right, so we'll put it over here. $1,259.12. Now we'll do it again. 1,000 times parentheses 1 plus 0.04 close parentheses raised to the 6th power, and I end up with $1,265.32. And then I'm going to go down to the quarterly guy. 1,000 times parentheses 1 plus 0.02 close parentheses raised to the 12th, and I get $1,268.24, and then last guy, 1,000 times parentheses 1 plus 0.08 divided by 365.25 close parentheses raised to the 3 times 365.25 power. Boom! And I end up with $1,271.21. Okay, good enough? So I can compound daily, from quarterly to daily, and I get all the $3 more. Okay, anybody out there getting 8% on any money at all? No, we don't get that anymore. We get like 0.01. Yeah, percent. Yeah. I can remember that. I can remember Dakers have to deal with. Okay, that was the last problem in this set, so we're going to go to 9-2. 9-2. Now, before we had calculators, we had slide rules. And our slide rules allowed us to multiply, divide, take square roots, take squares, take logs. And the way we did that is that when you add logs, if you add log A plus log B, that's the same as taking the log of A times B. So if I had a ruler marked off in logs, so there's my 2, and there's my 3, and there's my 4, 5, 6, 7, 8. And I had another one marked off in logs, and there's my 2. I could go 2 times 2 is 4. And they'd line up, and life would be wonderful. And I do my math on my slide rule. And I was rather proficient at that because we didn't have slide rules. We were still using slide rules in '72 at Michigan State. No one had a calculator yet. It wasn't until I got to Naval Postgraduate School in '78 that I bought a first calculator and did things like that. Anyway, the issue is if I have y b to the x, that equation is the same equation as if I say the log base b of y is equal to x. So these two things are equivalent to each other. If I see this guy and it's more convenient to solve that equation, I do. If I see this equation and it's more convenient to solve that one, I do. They're the same thing. So the log base b of y, so it'd be the log base b of b over x. So the log base b of b over x would be the exponent x. And that's what I'm doing there. Yeah, a little weird, but can't have everything. Okay, a log of anything, so I have a log of anything, is going to always be positive. Okay, so I can't take the log of it. No, that's not true. The log of something, this has to be positive. So I can't take the log of a negative number until you get to imaginary numbers. Then it turns out in imaginary numbers, this is the real axis, this is the imaginary axis. I can't take the log of a real negative number, but I could take the log of this guy up here. So it'd be perfectly okay in imaginary numbers to take the log of minus 2 plus 2i. I can take the log of that because that's not imaginary. That's not negative. That's that vector. But if I'm sitting on the real axes and I'm sitting there at minus 4, I can't take the log of minus 4. That's not allowed. So in section 9, where we don't have imaginary numbers yet, we just say the obvious, which is we can't take the log of a negative number. Okay, now when I was doing the graphing and I had y was equal to bx, I was saying, well, this guy is always going to pass through 1, right? And look something like that, maybe, or something like this, depending on whether or not I'm positive or negative sitting there on my x, or my b, or whatever. The log guy is going to do the same thing, but he's going to pass through 1 at 0. So when the log of 0 is going to be 1, and I'm going to have a function that looks like that, or a function that looks like this, depending on whether or not I'm positive or negative. Okay, so much for the theory. back to working problem number 3. So I'm supposed to express the equation in logarithmic form. So there's my equation. So I'm going to take the log of base 5, 125 is equal to 3. That's all there is. There ain't no more to the problem. Okay. There's my base. It's 5. I put it here in the base of my log. Now, my calculator will only do log base 10, which are known as common logs, and natural log, which is base E, which is 2.718281828. And E is a transcendental number. It never repeats itself. It never quits. It goes on forever. So that's just one of those things. But those are the only two things my calculator is going to do. I'm not going to be able to do logs of, other than common logs or base the E. But one of the weird things is if I have log base 7.35 of 8.41. Okay, so I got that. This is going to be log, common log, 8.41 divided by common log 7.35. It's also the natural log of 8.41 over the natural log of 7.35. Put those guys in your calculator and see if they come out to the same thing while I start working on problem number 17. Problem number 17, write each equation in exponential form. Okay, so number 17. I have log base 25 of 5 is 1/2. Alright, so that I'd end up with 25 to the 1/2 is equal to 5. Yeah, the square root of 25 is 5. Yeah, okay, that's fine. So did your calculator say that those guys are the same? It didn't, because no one bothered to do it right. So your calculator's pretty stupid. I don't believe the calculator can't do it without you guys pushing buttons. I mean, really. Huh. So it doesn't matter if I use common log or natural log, that those two numbers are the same number. I know you all believe me, but after April, I did bring in my birthday card that I got from my grandchildren, so to show it to you guys. Well, I guess the only real thing to do, there's only one honest person in the room, right? That's Justin. You guys wouldn't believe anybody else, right? What does it say on the birthday? Says one here. You gonna believe him? Has he got an unbelievable face? He's a shaggier bird. He's a shaggier bird than Ben does. I don't know if I'm going to believe him. I mean, gee, really, you're going to believe him? 1950. Yeah.
Why it says that's your fake ID from when you were 18?
Yeah, probably. Yeah, that's my fake ID. It looked like it, didn't it? Yeah. Okay. So we have one more problem to do, and that's number 40.
Let's answer number 3.
Oh,
Or never mind, not number 3.
Don't want to know the answer to number 3? All right.
Well,
All right. All right. Number 40. Now we're supposed to solve for x. Okay, so log base x of 1 over 27 is equal to minus 3. Now we look at that and we say, well, that's not convenient. I'm going to put it in exponential form. So that what this is that if I have x to the minus third, I'm going to get 1 over 3 cubed, which is 3 to the minus 3, which clearly implies x is 3. Okay, so looking at it in exponential form, it's not so intuitive that x is a 3, but as soon as I put it into the form of a exponential function, it becomes very obvious that x is going to be a 3. Okay, any questions? No? Okay. With that, we will call it a day.